Welcome back to the Math Professors. If you're looking for content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and we're going to cover graphing exponential functions, and we're going to have a nice process here to show you how to do this. So our process is, of course, I'm going to give you an example, and then what we're going to do next is we're going to find the x and y intercepts. We're going to determine the transformations on the parent function, and what I mean by the parent function is we're going to have a f of x, which is equal to some base to the x. You know, that base might be different for every function. In this case, this base is 2. Next, we're going to figure out where the point 0, 1 goes through, because all exponentials in its parent function form go through the point, well, when you plug in x equals 0, anything to the 0 power is equal to 1. So we're going to determine where that point transforms to through this transformation. We're going to find the horizontal asymptote, and then we're going to finally graph this thing. All right, so starting with this, what I know is this function comes from a parent function of f of x, which is equal to 2 to the x. All it's been done to this 2 to the x is it's been transformed. So let's first start out with the x and y intercepts. Well, the x-intercept, we know this happens when y is equal to 0. And then we can also find the y-intercept, and we know this happens when x is equal to 0. So first, when I solve 0 is equal to 2 to the x plus 1 minus 4, when we're solving these exponential functions, what we do is we just isolate, essentially the funny thing is kind of the way I go about it, isolate the most complicated structure, in this case being the exponential term. So I'm going to subtract or get rid of that subtraction of 4 by adding 4 to both sides. Now, since these both have a common base of 2, because 4 can be written as 2 to a power, so this is 2 squared is equal to 2 to the x plus 1. And since exponentials are 1 to 1, that means that if the bases are the same, then their exponents must be the same. So that means 2 is equal to x plus 1, which then subtracting 1, x is going to be equal to 1. So what we have is we have the point x is equal to 1, y is equal to 0. Now the y-intercept isn't going to take algebra because we don't have to solve for x, we're just going to evaluate for y. So plug in an x equals 0, we just evaluate this function at 0. Now 2 to the 0 plus 1 is just 2 to the 1 minus 4. So 2 minus 4 is going to be equal to negative 2. So now what we have here is I have 2 points. I have the point x is equal to 1 and y is equal to 0. And I have the point x is equal to 0 and then y is equal to negative 2. So those are your x and y intercepts. Now, next we're going to find the transformations on this function. So we're going to do step 2, find the transformations. Well, what do these things do to this function? Well, let's handle the shifts left and right. You know, these are the operations on the x's, you know, what happens up here. So what I know is adding 1 means that we're going to shift this thing left 1. And subtracting 4 outside of the parent function is going to pull this thing down 4. So this is now going to be down 4. So what we're going to now do is for 3, I want to know where this point 1, 0 goes to. Because right now, again, this function, the parent function, goes to the point 0, 1. And I need to know what happens to this. Well, if I go left 1, what this 0 is now going to become negative 1. And then when I go down 4, this y is now going to be equal to negative 3. So now I have another solution point. So I'm going to kind of keep a list of solution points over here. So this solution point now is going to be negative 1, negative 3. Let's go ahead and find the horizontal asymptote. Well, what we know is for the parent function, we know that exponentials look like this, that the parent function goes to the point 0, 1, and we know that it has a horizontal asymptote of y is equal to 0. So that's the horizontal asymptote of its parent function. And what happens is when this thing shifts down, it's now no longer going to be at 0 here, now it's going to be down at negative 4. So this is going to have a horizontal asymptote of y is equal to negative 4. Finally, we can graph this. So now I have a bit of information. Let's do our solution points first. We know that it goes to the point 1 comma 0, so over here. We know that it goes to the point 0, negative 2. Here. It's got another solution point of negative 1 comma negative 3, so this is going to be equal to negative 1 and down 3. So another solution point right here. And it's got a horizontal asymptote of y is equal to negative 4. So at negative 4, we have this horizontal asymptote. Now, again, really just following this, that we know that this thing went left 1, down 4, we can tell that this function now looks like this. So that is the graph of this. So if you like the content, please consider liking, subscribing, and sharing.